When you're trying to teach an AI to do something, you've got to answer this surprisingly deep question first. How do you define winning? Do you want the AI to get a nice, steady stream of points? Or do you want it to achieve one single, spectacular, brilliant moment? As it turns out, that choice is one of the biggest challenges in artificial intelligence today. And that question right there is really at the heart of a whole field called reinforcement learning. It's all about teaching an intelligent agent how to make decisions, not by just giving it the rule book, but by letting it figure things out all on its own. Okay, so the basic idea is actually pretty simple. Think of it like you're teaching a dog to fetch. You don't write down a list of instructions, right? You just throw a ball, and when the dog finally brings it back, you give it a treat. That treat is the reward. And the AI learns by trying millions, even billions of different actions, just trying to get the biggest pile of treats possible, what we call the highest cumulative reward. But, and this is a big but, here's the catch. What sounds so simple in theory is incredibly difficult in practice. Handing out those little digital treats, designing what's called the reward function, is a notoriously tricky problem. And if you get it wrong, you can end up with some really, really weird results. When developers are designing these rewards, they run into this classic trap. On one hand, you've got what are called sparse rewards. This is like a single huge prize at the very end of the level, a pot of gold. The problem? The AI might just wander around lost forever and never even find it. So, on the other hand, you have dense rewards, a constant stream of little points, like breadcrumbs, to guide it. The risk there? The AI might just figure out how to game the system, spin in circles, collecting easy points without ever reaching the real goal. Yeah, this is what researchers call getting stuck in a local optimum. It's like the AI finds a strategy that's fine, it gives it a decent, consistent score, but it's not the best score. It basically gets satisfied with being mediocre, and it stops exploring for that big breakthrough that would actually solve the problem. But what if, this whole time, we've been thinking about rewards completely backwards? A new paper from researchers at Delft University of Technology is proposing a pretty radical shift. They're not just tweaking how we give out rewards, they're changing the entire definition of what it means to win. So, I want you to meet Max Reward Reinforcement Learning. Forget everything about adding up points. In this new world, the AI's only goal, its only goal, is to get the single greatest reward it possibly can in one moment. It's not about the average, it's all about that one single peak performance. And right away, you can see how this makes a developer's life so much easier. You don't have to carefully balance a million tiny rewards anymore. You just have to make one thing crystal clear for the AI. See that thing over there, the final goal? That's worth the most points. Go get it. Simple as that. Okay, I know what you're thinking. This sounds almost too simple, right? And, well, at first it was. Early versions of this idea worked just fine in worlds that were predictable and orderly. But the real world? It's messy, it's random, and when you introduce that randomness, the whole simple approach just completely falls apart. So let's look at this diagram because it shows the problem perfectly. Imagine the AI has two choices. Path 1, on the left, has a 50-50 shot of giving a massive reward of 12, or absolutely nothing. Path 2, on the right, also has a 50-50 shot, but its best possible outcome is only 9. Now, logically, you'd want the AI to go for Path 1, to take that shot at the huge 12-point prize. But a simple max reward AI gets confused by the randomness. It gets tricked and ends up playing it safe, choosing the worst option. So how did the researchers get around this? How did they solve this puzzle? Well, their solution was just beautiful, so elegant. They decided to give the AI a memory of its own success. Technically, they introduced something called an auxiliary variable, but we can just call it Y. Just think of Y as the AI's personal best score. So now, at every single step, the AI isn't just asking, where am I? It's asking, where am I, and what's the highest score I've ever seen so far? Its new goal becomes incredibly simple: beat that score. This little bit of memory prevents it from ever being fooled by randomness again. All right, so a fancy theory is great and all, but does it actually work? To find out, the researchers threw their new Max Reward AI into some pretty tough virtual challenges to see how it would stack up against the old way of doing things. So first up, a maze. The AI is in control of a little ball, and its one and only job is to find the goal, that red sphere you see there. And to make it even harder, they tested it with both one goal and sometimes two possible goal locations. And the results? Honestly, they were night and day. When there was only that sparse reward at the very end, the standard AI, the one trying to add up points, just couldn't do it. It failed to learn. It just wandered around aimlessly. But the max reward AI, with its laser focus on that one big goal, it solved the maze efficiently every single time.
But, okay, mazes are one thing. The researchers really wanted to turn up the heat. So next, they moved on to these robotics tasks. We're talking about a complex 7-degree of freedom robotic arm. Its job is to move a puck to a target, and sometimes it even has to slide it into a spot it can't even directly reach. This is hard stuff.
And once again, total blowout. Look, these kinds of robotics tasks are famously difficult for standard reinforcement learning. So no surprise, it completely failed. It couldn't learn what to do. But the max reward agent, it nailed it. Learned the complex moves, got the puck to the goal, and consistently succeeded.
So what's the big takeaway here? What does this all mean for the future of AI? Well, the payoff from this huge shift in thinking is a path for training AI that's fundamentally simpler and way more effective.
Okay, so let's break down why this max reward idea is so powerful. Well, it really boils down to 3 things. First, the AI gets a much clearer signal about the true goal. Second, that personal best memory keeps it from getting stuck on just good enough solutions. And maybe most important of all, it makes the human designer's job much, much easier.
The bottom line is this. We could be looking at a technique that makes it way faster and easier to train AI for really complex real-world stuff. Think robotics, logistics, even things like scientific discovery. By simplifying how we tell an AI what we want it to do, we can unlock its potential on problems we used to think were just too hard.
And that really leaves us with a huge, fascinating question. If we can now teach an AI to focus on the ultimate prize instead of getting distracted by small wins along the way, what kinds of seemingly impossible goals could finally become reachable? The possibilities are, quite literally, to the max.